We want to welcome everybody to Animal Science 109 again. This evening we've got Dr. Scott Lake with us. Dr. Lake is the associate professor here at the University of Wyoming and is the animal livestock extension specialist. I get the opportunity to work with him quite a bit on some various projects. And so we're grateful to have him here this evening. And he's going to visit with us about reproduction, some aspects of that. So Scott, Dr. Lake, I'll turn it over to you.
Perfect. Thanks, Jonathan. So it's good to be here tonight. I'm not sure. So what did I see? There's like 4 people here. Is that right? Anyway, that's fine. So my first slide, I guess what I'm going to do tonight is I'm going to go through a few. Let me turn my phone off so somebody doesn't call me. I'm gonna go through a few. I can hear it. Anyway, that's better. So we're going to talk about some of the fundamentals of detail. Hey, Jonathan, are you picking that up? Jonathan, are you there?
Yes, I am. Can you hear me, Scott?
Yeah. Are you hearing that weird background noise?
No.
And it sounds like something really banging loud. A little distracting. All right. If nobody else, can anybody else hear it? All right. Well, I'll just try to muddle through it then. Whatever happened, it's better now. So anyway, sorry about that. So what I'm going to talk about is the fundamentals of reproduction. The challenge of this kind of course is that, first of all, I'm not seeing you face to face. So I can't tell if you're confused, if you're sleeping or whatever. And the other thing is I don't really have a great feel for your background. I mean, I know all of you guys are in high school. I don't know how much reproduction you've had, okay? So forgive me if I sometimes get too basic, but we're going to talk a little bit about reproduction, about cells, about fundamentals, and then I'm going to transition over to beef cattle and talk about reproductive management in a beef cattle herd. So let me try asking a question here. So I'd kind of like somebody to respond. You can see my first bullet point there is, so the purpose of reproduction. Obviously, the main goal of reproduction is to perpetuate a species, whether that's people, cows, whatever it is. So it says that reproduction is nature's second strongest impulse. What is the first? What would you guess is the number one impulse that any animal has? Us as people, animals, whatever. So somebody try to answer that. I want to see if we can make this work. What's the number one impulse that we would have?
Is it food?
Oh, nice. So I can hear somebody. So food is a good answer. Our ability to survive, right? We want to maintain ourselves and survive. So food would fit right in there. So perfect. Thank you. The second big thing is provision of food. The reason we want, for farm animals, we want to have them reproduce is for provision of food. We can use animals basically as a food surplus, right? That's why we raise animals. We have to eat. So certainly they provide food for us. Genetic improvement. That goes without saying, I think. First of all, the species wants to perpetuate itself. Now, in a livestock environment, we are manipulating reproduction, and we'll talk about AI and those sorts of things maybe next time. We'll talk a little bit about it tonight. But that's one of the biggest tools we've got from artificial insemination, from embryo transfers. We're trying to improve the genetic quality of beef cattle or sheep or whatever it is that we're breeding. And so we're always selecting for, on the food side, we're selecting for animals that grow more, fit our environment, that sorts of things. So they're more efficient, make us more money. But the bottom line is to make food more efficiently. So I'm going to talk about this now, but the success of any reproduction system is going to be the coordination between the endocrine system and the reproductive anatomy. So let's talk about those two systems, okay? I'm going to hammer this into you probably every time I talk to you about reproduction. And when we talk about AI, maybe we'll even get more into this. But So as a beef cattle guy, whether I own a few cows, but I talk to people that own a lot of cows. And, all of us go to bull sales and we look through AI catalogs and we're selecting, we want these big growthy bulls that do really well and look good and all that sort of thing. The number one trait that we ought to be selecting for is reproduction. It's the most economically important trait in all of animal production, whether it's cattle, sheep, goats, whatever. So keep that in mind. We can select for growth. We can select for, if you're into showing, the cool looking ones, structurally sound ones, whatever it is, reproduction is the single most important trait. So never lose track of that. So obviously, the more animals we have, the more we have to sell if we're in the business of selling them. And we are, whether we sell them at weaning, whether we sell them at through slaughter, whatever it is, we're going to ultimately sell that animal to try to make money. So if we select for reproduction, we've got more animals to sell, therefore it's more profitable. The better reproduction we have, the better amount of replacement females that we can select for. And we're going to talk a little bit. If we have time tonight, I might get into it. I don't know. We'll see how this goes. But we'll talk about heifer selection and the things that my opinion would be are important. And most of it's scientifically based. There's probably a little bit of my opinion in there. But a lot of it is scientifically based. And reproduction obviously initiates lactation, which is going to feed that newborn calf or newborn animal. And then reproduction determines the number of eggs. So first of all, we got to be able to measure reproduction, right? So simply, a measure of reproductive efficiency is simply the number of animals born divided by the number of breeding animals. So if we take 100, I always use 100 in all my scenarios because it's easy math. So if we have 85, let's say calves, we have 85 calves born out of 100 cows, we had an 85% reproductive efficiency. Okay, so there's benchmarks that we want to hit. Our conception rate, which is actually getting a cow bred, is always going to be much higher than our actual reproductive efficiency because we're going to lose animals, we're going to lose embryos or fetuses during pregnancy, and then we're also going to have some death loss once they're born. So we're rarely going to hit 100%. And now maybe I'll tell you how we can hit 100%, right? If you look at, let's say, lambs, it's not uncommon for a person to tell you they had 100% or 105% lamb crop. Well, that's because you have twins and triplets. So they're making up for the ones that either didn't breed or died at birth. I actually talked to a beef producer this year that he had a pretty marginal part, pretty good set of cow. I don't mean quality. I'm talking number wise. He had he was in the couple hundred, so pretty good sized herd, really high quality animals. And he had over 100%, or he reached 100%, and it was the first time he'd ever done that. And he had, I think, 6 sets of twins that lived, and that made up for the 6 calves that died for it. And therefore, he reached 100%. So those kind of things can boost our numbers a little bit. So let's talk a little bit about some anatomy here. I think when you guys were here last spring, if I remember correctly, and we teach a lot of these courses, so forgive me if I don't remember exactly, but I'm pretty sure we laid out a reproductive track for you, and we talked about those things. But here is. Does somebody have a question?
See, I was just going to say yes, that's true. It was our class. You laid out a track for us, so.
Okay, thanks. I thought that's right, but. So here's a schematic of the reproductive diagram of a cow. So obviously, vulva in the rear here sits below the rectum. You got this long tubular organ, which is the vagina. We got the cervix, and I'm going to talk about all these organs a little bit more in detail later. The uterus is really important. All of these right here are really important from a reproductive standpoint. The ligament kind of holds everything in place up there, so it doesn't just hang off the pelvic rim there. Oviduct, we've got the bladder. If you AI cows, that's really important. It's actually amazingly easy to thread your rod right there in the bladder and get that rod in the bladder. And we're not really an AI class right now, but when you do that, there's no doubt about it because she does not like it. So she will jump all over the place, kick the crap out of you, whatever it takes, and she doesn't like it. But these structures are really important, and let's talk more about them as we go. Here's another schematic, kind of the exact same thing, but just a different view. You can see the rectum up here. Again, this is a cow. And so if we were AI in this cow, remember, we go in with our arm rectally, okay? And we're going to stick that rod in through the vulva, right here through the vagina. We're actually going to pass that rod through the cervix, and we want to deposit that semen right here. Now, can anybody tell me, and you can either turn on your mic or in the chat, where does a bull deposit semen? Or, in sheep, if it's a ram, where do they deposit semen at? Does anybody know? As an AI technician, we want to deposit it right here, right on the inside of the cervix. You guys are probably, the answer and you're just being a little shy. But so a bull, ram, they're going to deposit semen in the vagina, right? So that semen's got to transverse all the way across this cervix. It's going to go up this uterine horn. The uterine body is right here. The horn bifurcates, so it can go up either side. This yellow string out here would be the oviducts, and these are the ovaries sitting out here on the end. And so I'll continue this as we talk along, because I think I have some better views coming up. But does anybody know? Let me ask a few questions here, and again, I'm not sure how successful these questions are going to go. Does anybody know where a embryo implants and grows? So when a cow is pregnant, it's got this embryo that implants in it. It grows up. Does anybody know where that occurs at? Take a guess. There are wrong answers, but I promise I won't make fun of you. Well, implantation occurs in the uterine body. So that's going to be right about here. But fertilization occurs all the way up here in this oviduct. So that semen or those sperm cells have got to transverse this all the way up this uterine horn, and fertilization is going to occur up here. So in a cow, that fertilized embryo will migrate all the way down here and implant in the body of this uterus by day 7. So it takes about 7 days to get there. Okay, so here I kind of got ahead of myself. Here's some structures, obviously in this one, vagina, cervix, we talked about that, uterine horn, oviduct, infundibulum. That's going to be kind of think of it as a catcher's mitt. We got the ovary out here, it's going to ovulate. That infundibulum kind of surrounds it, and it captures that egg that's being released. All right, so here's a blown up schematic of that. We've got this infundibulum right here. We got some technical terms. Ampulla, the isthmus, right in here in between them is generally where fertilization is going to occur, okay? So that's the junction we're looking for. That's where fertilization has to occur. And now we're going to talk a lot about AI as we go through this program. Excuse me. We want that semen to be here. And I'm going to show you some slides about the lifespan of semen and eggs in a few minutes. But we want to synchronize her, to know her system, to be able to read signs of her being in heat, breed her at the correct time, and have that semen up here waiting before she ovulates. Because we want it to occur here. If we are, let's say, a day late and she's already out here, the egg being out here, it's not going to be alive anymore. So fertilization will not occur. Okay. So here I've put together a few different diagrams of, this would be the uterine body and uterine horns of different species. So there's some interesting ones out there. These marsupials, they actually have 2 cervixes and 2 vaginas that come through. It's kind of complicated. Here's mostly what we deal with: cow, a sow here on the bottom, and these are called bicornuate. Probably not a lot right now that I want you to remember that. Some of the differences. So remember what I said. Up here is the ovaries, going to have the oocyte. It's going to ovulate. It's going to migrate down in here. Fertilization is going to occur up here. And that embryo is going to migrate all the way down here and implant in the body of that uterus. Okay. Some of the differences that are kind of interesting in the mare, they actually will, it doesn't necessarily implant like the cow does. It will actually migrate back and forth for a long time. And that actually, there's some benefit to that, and it aids to maternal recognition of pregnancy. But each species has its own differences they're pretty interesting when you study it. We're not going to talk about that right now. So here's kind of a bisected view of that uterine horn. Okay, the cervix sits in here. We're going to call that the gatekeeper, right? So from an AI standpoint, the cervix is the most important organ that you can find, or that you need to find, because that's going to be what allows you to get to the right spot. If, as an AI person, you deposit semen in front of the cervix, your chances of pregnancy are probably less than 1%, very, very small. And so the natural question is, well, why does the bull have such good luck? Well, he is depositing, I don't know what the volume on is, but multiples of 10 times more than we are depositing. So he's putting a lot more in there. Fresh semen always has more longevity than manipulated or frozen semen. So that's why we have to put it back there. Okay. So here's a schematic of the ovary. All right. Now, does anybody know what functions the ovary has? Obviously, it's going to release an egg, but does anybody know what hormone it produces? Okay, the ovary and the testes, they are steroidogenic, right? They produce steroids or hormones. So does anybody know? Oh my God. Okay. So the question is, how long is the distance from the entrance of the cervix to where insemination occurs in the uterine horn? Inches, meters. From the entrance of the cervix to where insemination. Okay. So let me back up a slide to answer this. So just to make sure everybody heard the question, I don't know if you can see it. Thank you. Estrogen is the correct answer. So I'll come back to that. How long is the distance from the entrance of the cervix to where insemination occurs in the uterine horn? Let me back up one slide. So if this is our slide, the entrance of the cervix is right here, and we want to deposit it right here. So in a heifer, that can be as little as an inch, inch and a half. In a mature cow, it could be 3 or 4 inches, maybe 5 or 6 at the most, but usually about like that. So, okay, so the next question was, or the answer was estrogen, and that's correct. So as these follicles develop, when it gets to this stage where it's a antral follicle, mature follicle, it produces a lot of estrogen, okay? And it's going to be in this fluid is where the estrogen occurs. So, I mean, generally, what we've got, I mean, the ovary has, I don't even remember the numbers, 75,000, I want to say, 75,000 potential oocytes in it. Now, as a percentage, very few of those will actually reach maturation, right? So there's a whole pool of them in here, and there's going to be a lot of hormones between LH and FSH that recruit them, and we'll talk a little bit more about that in a minute. But we're going to have this oocyte come up and become a primordial follicle. It advances to a secondary follicle, which starts to develop this zona pellucida. One of these times when I have you guys here, we're going to do a lab, and I'll actually pull some embryos out that you can see, and you'll be able to see that zona pellucida around it, and that's what actually protects it. Now, once it's fertilized, and after it develops, it will actually hatch, and so that zona pellucida will break, and that's when implantation will occur. But for our purposes right now, that zona pellucida is very important to protect that oocyte and then eventually the embryo, okay? So once this develops into our primary or mature follicle, once it gets the correct LH, FSH response, and endocrinology can be really kind of complex. I'm going to keep it kind of simple, but there's a lot of positive and negative feedbacks. So negative feedback would be if we have a really high level of progesterone, that's going to have a negative feedback on estrogen. So when progesterone's high, we're going to have very low estrogen, okay? So a positive feedback would be when we have really high levels of LH, it's going to increase the response and get, actually, I said it the wrong way. When we get high levels of estrogen, it's going to increase LH, and that will allow for ovulation, okay? So once this ovulates and we get the oocyte that goes into the infundibulum and down, we form a blood clot here, okay? But then it quickly turns into what we call a CL, or corpus luteum. Now that stands for, it means yellow body. And if you actually see one, and I think I got some actual pictures on one of these presentations I've got, so I'll show you, but it actually is yellowish in color, okay? Does anybody know what hormone that produces? So that fills in with this CL tissue, and it's going to actually form a mature CL, and it's going to produce a hormone. Can anybody tell me what that is? It's not estrogen, I'll tell you that. We're producing estrogen up here. So after it ovulates, estrogen goes back down. So this CL forms, and it's either going to maintain pregnancy. So that's kind of a hint, right? This hormone that I'm talking about, we consider to maintain pregnancy. Somebody's guessing. Not sure what that means, but so it's going to be progesterone. Okay, so we are going to consider progesterone the hormone that maintains pregnancy. So this CL will start producing progesterone. When we talk about, so I'm getting some weird question on here, but it's just pluses and minuses. I don't know what that means, but anyway. So progesterone is going to maintain pregnancy for us, and it's going to stay out there for, say, 14 days. It's not going to peak until day 6, day 7. What the heck is going on here? So I don't know if somebody just...
Yeah, sorry, Scott. I'm not sure what's going on there. Just keep plugging away. I'll try and figure it out with Rebecca.
All right. Sounds good. So progesterone is the one we're talking about. We'll talk about this more later, but how many people by show of hands on this thing have ever dealt with a synchronization protocol? How many people have ever synchronized cows? Can I get a count? Has anybody? So I'll take that maybe as a no. So we will go through synchronization protocols at a different time, but these are, these are all the things that we're manipulating. We're going to manipulate when she ovulates, so we can actually manipulate when those follicles grow up. We can hold them using hormones. We can give them other hormones that will kill this CL and allow them to ovulate. And so this is exactly what we're trying to manipulate in a synchronization protocol, is all of these different things we're talking about. So you would be surprised, when we teach AI schools, we kind of go through this. And I think it's important that people know where progesterone is produced, where estrogen is produced, what will kill the CL. You'd be surprised at how many people call and they get the shots mixed up or backwards, and they want to know if that matters. Yeah, it does matter. So here's our picture of a graphene follicle. It's just kind of a picture. We've got the oocyte in the middle. All of this is going to be fluid around here, and it's going to be really high. Excuse me. These granulosa cells are going to be really high in producing estrogen. So there's a lot of estrogen in here. So if you think about the growth, I think this next picture is this is kind of a cool picture. This shows when the follicle ruptures. So this process is called ovulation. When that follicle ruptures, the fluid from granulosa cells, and it's containing high amounts of estrogen, okay? So this is the corpus luteum. Once she ovulates, this is the schematic is representing the cavity that it left. And so it's going to fill in with a blood clot that quickly turns into this corpus luteum. And this tissue here is what's producing progesterone. Okay? So let me get all of these on here. You will hear estrus and estrus, right? They're pronounced the same, but there's differences. Estrus, as in US, is the period of time when female is sexually receptive to heat. So when we talk about her being in estrus, that's estrus as in US, okay? When we talk about the estrous cycle, it's OUS. So that's really important. Reproductive physiologists get really annoyed at that sort of stuff. So keep it right. Really, it really doesn't mean anything for our practice purposes. Does anybody know what causes an animal to stand? When we say that she's in heat, what hormone is making her sexually receptive to want to be bred? Can anybody answer that? We talked about it already. In fact, somebody mentioned it. Let me see.
Yeah, Rebecca sent it to me privately.
Yeah, okay.
Estrogen, she typed.
Nice. So perfect. Estrogen, what causes her to stand? So she's going to produce low amounts of estrogen early in the cycle. And I will show you, in fact, I think it's the next slide. Let's move to that. So right here, if this is day 0 is ovulation, okay? So our estrogen, this dotted line here, was our estradiol concentrations, estrogen level. So it was really high. But once she ovulates, we're releasing all of that estrogen, so it kind of crashes down. Now, this blue line is our P, stands for progesterone. Usually you'll see is P4. Estradiol would be like E2. So you'll see this increase. So we get out here to day 5, 6, 7. This is where we've got peak progesterone concentrations, okay? So you'll see that it slowly builds up because it takes a couple days for that tissue to build up in there and start producing a lot of progesterone. Now, I'll come back and talk about this at another point, but there are some protocols out there, synchronization protocols, that we give a prostaglandin shot on day 5, okay? And that kills the CL and allows her, drops it off. Well, day 5, you can see that this is still a very new, growing CL. It actually doesn't respond to prostaglandin, so we have to give them a double shot. And I mean, we'll talk more about that later, but then you can see when we get out here, it will actually die. So if she was bred, if we got this cow or sheep or whatever pregnant, out here, when we get to that day 14, we usually consider maternal recognition and pregnancy. So each species got a different protein that they release. In cows, it's called interferon tau. They will actually release that. The fetus actually releases that, and the body will recognize it. And she will, there's obviously a lot of receptor signaling going on, but her body will recognize that she's pregnant, and that CL will maintain, so it won't die, and it maintains pregnancy. If we don't get that signal, it starts to die, and progesterone drops off, and we get this natural cycle going. So here's a little bit more detailed diagram, same as the last one. Down here on day 0, we got ovulation, okay? So this would be our estradiol concentrations. It drops off. Now these down here are waves. So when we get follicles developing, in that prior diagram I showed you, we had one, that started out primordial and went all the way up. Well, it actually occurs, there's a bunch of them. If you take an ultrasound scan of an ovary, you'll see 15, 20 little follicles growing up. And then they'll reach a stage. Right here you can see there'd be a bunch of them. And then we get a couple of them that start to separate out. Now, in the natural cycle, progesterone is preventing those follicles from continuing to develop, right? So we'll come up here and get one, but it won't quite reach what we call a dominant follicle. I mean, we still would call this a dominant follicle, but it's not going to ovulate. So it will actually regress and die off. Well, the hormone FSH is in here. That calls the follicle stimulating hormone. That's actually like recruiting follicles. So it'll build up these follicles in here. We'll get some of them die off. We'll get one of them that kind of becomes a dominant follicle. Well, at that same period of time, our CL is dying. So when that progesterone crashes, the resulting signal is we get an increase in estradiol, we get a pulse of LH, and it allows for ovulation to occur. So, I mean, that's kind of a lot of information. We're covering a whole bunch in a fairly short period of time, and I'm not done, but I'm just asking, is there any questions? Have I lost you? Is everybody hanging in there? Anything that I need to reiterate or clarify? All right. So let me jump all these on here. So this is the same diagram we had before, but this time I'm showing you where FSH and LH come in, okay? So as I told you, FSH is important for the recruitment of follicles. If anybody has ever been involved with, and you probably haven't, but if you've heard of embryo transfer or super ovulating a cow, we give her a protocol of FSH. So the FSH is what we do is we're giving them way more than they need to have. So we are trying to get 10, 15, 20 follicles up here that are big enough that we can ovulate them at one time. And we can do that through manipulating them. In the natural cycle, FSH is responsible for that recruitment of cells, and then we get the division of 1 or 2 that comes off, okay? So we get this estradiol, and here's that LH pulse that we get. Again, allows for ovulation. So I'm pretty certain, I got to visit with Jonathan after this, but I'm pretty certain I'm supposed to write you a few test questions. So I think these next couple slides would be really good test questions, okay? Yes, okay, thank you. So estrogen, we've kind of gone through these, but let's reiterate. So the hormone estrogen, the source, it comes from the follicle. Remember, the follicle, as it grows and gets big, it produces estradiol or estrogen. That causes her to stand, allows her to be receptive so that she will be bred. Here, the function of it, again, estrus, as in the behavior, the mating behavior of estrus when she's in heat. Excuse me. Okay, the progesterone, its source is the corpus luteum. As I mentioned before, it maintains pregnancy. If the cow gets a signal or the animal gets a signal that she's bred, that CL is going to live the life of the pregnancy, basically, produce progesterone, which maintains pregnancy. Now, I haven't mentioned prostaglandin before, but it's produced from the uterus. And what that does is it kills the CL. So if you remember back to that diagram, and I can flip back to it really easy right here. If you're looking back at this diagram, that's what's occurring out here. Is since there wasn't that signal that she's bred, the uterus starts producing prostaglandin. That prostaglandin works on the ovary and regresses that CL, causing the decrease in progesterone. Okay. Back here. So we get CL regression. So these are all drugs that we don't use estradiol, but we use progesterone and prostaglandin when we're synchronizing cows so that we can manipulate that CL and manipulate the growth of those follicles. Okay, FSH, it comes from the pituitary, and again, follicle development or recruitment, okay? LH also comes from the pituitary, allows for ovulation, okay? That's the one that I would be looking for is ovulation. All right, so this is, again, similar to some of the stuff I've shown you before, but this would be a cattle estrogen cycle of what's occurring on the ovaries. So on day 0, we've got, maybe this would be day -1, we haven't ovulated yet. So we've got a really big dominant follicle producing a high amount of estrogen. We've got an old corpus luteum here, okay? So we rupture that, day 0, we rupture that, she ovulates right here. So then we've got this ruptured follicle that's going to develop into a new corpus luteum, okay? It's early forming between days 2 and 5. We get out here mid-cycle, days 6 to 17, we've got a mature corpus luteum and it's producing a high amount of estradiol. Then if we don't get that signal that she's bred out there somewhere around day 14, 15, 16, we're going to start having uterine production of prostaglandin. PGF2 alpha right here is prostaglandin, okay? Prostaglandin is going to lyse that CL, which again allows for the hormonal cascade, which will allow her to ovulate. And here's another table that would be some really good test questions, okay? So here, I'm going to skip this slide. This is the exact same slide. I just converted it to pounds instead of kilograms. So everything that we do from a puberty standpoint is affected by weight. So when we feed calves hard, sorry, and I'm always going to relate to calves, but this will be true for most species. But when we feed calves, like if you know producers that creep feed calves, or maybe they're on really lush pastures and they got hard milking moms, so they get kind of fat early, they're going to reach puberty earlier. Same thing with sheep, probably to a lesser extent with mares. But so weight is really important, and I'll explain a little bit why. So if you look at the ages, the sow, those sows reach puberty between 4 and 7 months, somewhere around 150 to 200 pounds. Okay, a ewe is going to be 7 to 10 months, 60 to 75 pounds. Okay, a mare, 15 to 24 months, the weight varies. Okay, dairy cows, 8 to 13 months, somewhere around 600-ish pounds. Beef cows, 8 to 15. And there's a huge range in there. There's actually going to be, if we figure that the average beef cow producer weans their calves at 6 months of age, there's 20% of your heifers are probably already cycling in a good fertile herd. So that age is highly dependent on weight, and we can actually manipulate that. If we feed them high energy diets, we can get what we call precocious puberty, meaning they reach puberty before they naturally would. So here's some characteristics between the different species, okay? Cow length. I was going to ask you that question, but it showed it right on the diagram, so I thought pretty easy one. The estrus cycle in a cow is 21 days. In a sow, it's 21 days. A mare, it's 21 days. And a ewe, it's about 16 days. Now, if you think back to that diagram I showed you, and it's pretty easy to click back, so I'll just do that. So if we say that this is a cow and she's a 21-day cow, now 21 day is just the average. They're going to cycle between 18 and 23 days. And what affects that is how many waves of this she has. We can actually turn waves over fast, and we will have what we call 2 or 3 wave cows. So this is a 2-wave cow. She's probably going to come into heat about day 18 or 19. If we put a 3rd wave in here, she's probably going to be 22, 23. So when we say 21, it's strictly an average, and it's highly dependent upon how many follicular waves she's having, okay? The duration of estrus, how long she's actually going to stand. In cows, it's about 14 hours. Sows stand for a long time. Mares stand for a really long time. And ewes stand for a fair amount of time, okay? How long do they ovulate? How long do they ovulate after estrus? So this would be from the time that she first came into heat. From that point, how long is it? No, I'm sorry. This is after estrus, not after ovulation. So this would be once she stands and quits standing, she's going to ovulate about 10 hours after that, okay? A sow would be 18 to 60 hours. A mare, 24 to 48 hours. And a ewe, 1 hour before. A cow is pregnant for 9 months, 280. I think the Angus breed is average is 282 days. The sow is an easy one to remember: 3 months, 3 weeks, 3 days, 114 days. Okay. The mare is dang near a year. They're 11 months, and the ewe is 150 days. Okay. That would be a good table to know. Okay, let's talk a minute about the hen. And then I'm going to give full disclosure here. I know nothing about chickens, so I'm going to show you this slide and one more, and that's the extent of my knowledge. But what I thought was really, what I thought was really interesting about this is this whole process from, we'll say, ovulation down to where that egg moves through the system and is ready to be, basically, it comes out, is about 24 hours. So a very fast process. Okay, the chicken, they reach puberty at about 20 to 25 weeks. They have about 24 to 25 hours between ovulations. They will ovulate somewhere between 260 285 times a year. That's going to be highly variable depending upon nutrition. So, and it takes about 21 days incubation period. Okay, so this is really important when we talk about artificial insemination. How long does the semen last in the tract, and how long does the egg last in the tract? Okay, I told you before that if we're late when we breed, that semen isn't going to get there in time, okay? And this is why. Look at how long that egg lasts let's talk about cows, it's about the same. So that egg, once it's ovulated, will only last 8 to 12 hours, and then it's going to die. Semen will last 24 to 48. It's very dependent on bulls. It's also very dependent upon whether it's frozen or fresh. Fresh semen will last a lot longer in the track than frozen semen, which if you think about it, it has to. A bull breeds a cow when she's standing in heat. We haven't talked about this yet, but if a person breeds a cow, we artificially inseminate a cow 12 hours after she stands. So we're kind of giving this whole system a head start, but that frozen semen won't live in the track nearly as long as fresh semen. So something I will keep reiterating this when we talk about AI, timing is everything, but there's always cows that come in the middle of the night and we don't know exactly when they came in. So how am I supposed to breed 12 hours after that? Or maybe she comes in at noon. I don't really want to go out and breed her at midnight. So a good rule of thumb, we always breed what we call AM PM. So if she came in the heat in the morning, we'll breed her at night. If she came in the heat at night, we'll breed her the next morning. So just AM PM. If you're in doubt, breed it early, because you would rather be early than late, because that semen will last a lot longer than that egg will. Okay. So just a brief history of artificial insemination. It's first reported in some Arabian history in the 1300s. The first actual documented successful case was actually dogs in Italy in the 1780s. First farm animal study, 1900s. Okay, and then in 1930s, where we really started making advances in AI, and we've continually progressed since then. Now, obviously, we can sex semen, so we can buy semen if we want it to be for a heifer or a bull, and it's 90-95% accurate. So we've come a long ways. So I think I'll skip this stuff because this is more for an AI talk. But is there any questions on this stuff? Any questions on anything we've talked about on this presentation?
I got one.
Okay.
Okay, so on chickens, can you explain the cloacia kiss a little bit more?
So probably not. I told you, full disclosure, I don't know anything about chickens.
Okay, that's okay.
So, yeah.
Okay.
Sorry, I'm not a chicken eater.
That's the only question.
I don't even like to eat eggs, so I don't know.
What? What's wrong with you?
I don't know.
Hey, Scott, I got a quick question.
Yeah.
Dr. Lake, what led to the jump in the 1930s?
That's probably a good question. I don't know the answer to that, but what I would guess, probably the desire in dairies. When we start talking about AI, 95% of dairy cows are AI, and those dairy bulls are so mean that kind of is why nobody wants to have a dairy bull on the property. Beef cows, we say less than 10% of beef cows are AI. And most of the ones that are, it's heifers. So as far as the technology, I think it's trying to improve genetics, trying to get the cow that, most of it originated in the dairy industry. So you take those cows that are really high producing cows, maybe they're out of this bowl, so we're trying to propagate those genetics. Would be my guess.
Great, I got another one for you.
All right.
So quite often I see for sale embryos in auctions now.
Yeah.
When somebody buys an embryo, is it just the egg that needs to be then added with sperm and implanted? Or is it already a fertilized egg?
Yeah, so that's a really good question. And when we talk more about, I'll give you guys an embryo demonstration. We'll talk more about embryo stuff. But to answer the question, it's fertilized before you freeze it. So when you buy it, it's a fertilized mating. It'll have the cow and the bull.
Thank you.
So you can't, to my knowledge, we can't successfully freeze an egg, thaw it, and fertilize it. Now, in vitro fertilization, you can actually go, they're sucking the eggs out and fertilizing it in the lab, but it's before you freeze it. Normal embryo transfer, we breed the cow, flush that. So in vivo fertilization occurs in the animal. In vitro fertilization occurs in the dish, but both of them occur before it's frozen. Any other questions? All right. Hey, Jonathan, how long are we supposed to go?
Oh, typically an hour to an hour and a half.
All right. So I got this next presentation. And I'll skip through some of it because I didn't go through and start deleting slides that you didn't need to see. But so this is I end up giving this talk a lot at different presentations. But so we're going to think about the stuff that we talked about, and we're going to try to manipulate it on a management here. And I'm not talking about synchronization protocols, but how we affect it nutritionally, why it's important, and some of the responses we get, okay? So I told you I'm going to keep hammering you with this. Reproduction is the single most important factor with the economic success of a cow-calf producer, simply because more calves on the ground, more calves to sell. We still sell them by the pound. So even if I'm weaning off really big cows, but there's less of calves, but there's less of them, more of them's probably going to weigh more. All right. So when we talk about beef cows, we want a cow to calve every year, but it's not enough that she calves every calendar year. We really want her to calve every 365 days. So that means every time a cow calves, if you remember, our gestation length was about 282 days. That means we got somewhere plus or minus 83 days from the time she calves until we get her bred to make sure that we maintain what we'd call our yearly calving interval, okay? Now, the period of time from the time that she calves until she comes into heat again, we're going to call that our postpartum interval, all right? So nutrition plays a big role in that. We got to figure that it takes, in a healthy cow that's in good nutrition, it takes her about 21, 22 days for her uterus to shrink back down, what we'd call uterine involution. So size-wise and inflammation, from the birthing process, it kind of comes back down to normal. It takes about 3 weeks for that to happen. So even if we could get her to stand cycling, there's no way we're going to get her bred during that period of time. So that cuts into us. That means we've got 60 days to get her bred. All right. So let me skip to this slide here. So postpartum anestrus in beef cows. So here we've got calving down here, uterine involution occurring out to here somewhere. So then we've got what these lines represent is follicular waves. And I wouldn't expect you guys, if you haven't really studied beef cattle nutrition, but we will get what we call short cycles. So people will go out, I'll go out at day 30, day 35, and I'll see a cow standing and think they're cycling. And I try to breed her off of that heat, or I turn the bulls in on them. It's not a fertile cycle, okay? She will get out to a certain period of time, and then that cycle just dies, and she will restart. So her body never has time to recognize that she's pregnant. Excuse me. But a short cycle is not all that bad because it's kind of like priming the pump. So she has that short cycle, she ovulates, kind of gets the system going. Her next one is going to be a good fertile cycle. Okay, you guys have seen this before. So it's the exact same thing. This is everything we're trying to control in a beef cow. So, and the reason I keep throwing it up there is just, it's a pretty complex system. There's a lot of moving parts that we are trying to manipulate. But if we do it right, we can manipulate this system pretty successfully. Okay. So on average, it takes about 40 to 60 days in beef cows before she will start to cycle. All right. There's a lot of things that affect the postpartum interval. I'm going to skip this. I want to show you this graph right here. And I want somebody to step out a little bit and take a guess. So the question is if you look at this graph, what this is telling me, percent anestrus. Anestrus means she is not cycling, okay? This was a survey done. There's over 2,000 cows in this survey, so pretty big numbers at 12 different locations. Out at day 70, they measured these cows, and anywhere from 8 to 70% of them were not cycling. On this graph over here, same thing. A few less cows, but 56 days, the range is from 17 to 67. So why is there such a range? Why can we go from 10 to 70% of our cows aren't cycling by day 70? Anybody have a good guess on that? Anybody? Bonus points if you take a guess.
Could it be like possibly what they're eating, maybe?
Exactly. Good answer. Whoops. Didn't do that. So that's exactly why there's such a range. Cows that are in really good shape, I showed you a slide or two before. The average beef cow starts cycling somewhere around day 40 to 50 to 60, okay? That's for cows that are in really good shape. If we drive out across Wyoming and we can find cows that are in really good shape, they're probably cycling. If we drive through wheatland and you see them on irrigated meadows or they're being fed silage, they're in good shape. But if I drive out across Shirley Basin and see some range cows out there and they're being supplemented, they're pretty thin. They may not be cycling. So nutrition is the number one factor that's going to affect how long it takes them to cycle. Okay. So I show this next slide a lot. And I don't know if I can make the point in this class, but every year, so we spend an awful lot of time and money developing heifers. And getting heifers bred is not that difficult, okay? We can easily get 85 to 90% bred every year. 2-year-olds is where they're hard. So once they calve, they're milking for the first time, they're actually still physically growing, and they're trying to get their cycle going again nutritionally. It's a tough time for cows. So their postpartum interval as a 2-year-old is a lot longer, all right? But so then we get through that. We get 65, 70% of them will make it through that. So then we get out to where they're 3, 4 years old, 4 or 5. We consider them in their productive prime. We spent the money to develop them. We made it through the really hard year 2 and 3. And then we'll get out to year 4 or 5 and they'll fall out. They'll come up open and they fall out of our herd. And this is what, to me, explains that. Gosh dang it. This explains it. What this graph is showing us is that the later that they calve within your calving season, the higher percentage is that they're going to come up open in the fall. And that just makes sense, because if we have a calving window at all, in other words, we manage it, we don't just leave the bulls in year round, we pull that bull, these cows that calve a little bit late every year, that's why I said it's so important that we calve every 365 days. So let's take this scenario. Let's say she calves every 390 days, right? So she's losing 25 days a year. Well, I've only got maybe a 60, we'll just say a 90-day breeding season. We get out there by day 4 or 5, we've pulled the bull before she's actually ever cycled. There's really nothing wrong with her from a reproductive standpoint, other than that she calves a little bit later every year. Now, when we talk about AI and stuff like that, we can back those cows up. We can control that. But one point I want to make is that if you don't keep records and know your cows, you will never know that happens and never do anything about it. And if you sell a 4-year-old cow every year, you're losing money. Data would show us it probably takes out to date year. I mean, it depends on the operation, but it's going to take you 5 or 6 years before she has paid for herself and she's actually making you good money. So if we sell them as 4 and 5s, we're losing money. So really important. So maybe I was a little bit out of order there, but nutrition is the number one factor affecting that. Have you guys talked about body condition scoring? Do you guys know what a body condition score is? Anybody? Well, I'll assume the silence is maybe no. So I think, I don't know if I have any slides on here that show. Let me see real quick. Yeah, I do. Okay, we're good. So recommend. we recommend that mature cows are somewhere in between a 5 and 5.5 body condition score. And I'm going to show you the pictures here in a minute. 2-year-old cows, we want just a little bit fleshier because, again, they're growing and we need them to have a little bit more fat on them. Okay? So our body condition scoring is on a 1 to 9 scale. 1, 2, and 3 would be considered very thin. Rarely do you see a 1. She's almost dead. You're probably driving out in the desert. You will see some 3s out there. 4, 5, and 6 is kind of our target. 4, we're going to consider on the thin end. 5 is probably perfect. 6 is getting on the moderately fleshy side. In Wyoming, rarely do we see 7s and 8s. I mean, there's just not that many really fat cows out there. I graduated from the University of Wyoming, but my first job, I went to work at Purdue University. And in the Midwest, we rarely saw 2s, 3s, and 4s. We saw tons of 6, 7, and 8s because they got so much feed out there. And the cows are so big that but you have similar problems. So here's some good examples. Kind of the targets that we want to evaluate when we look at a cow. You want to, first of all, you look at how much belly she's got, but you look at her top line. Can I see her ribs? Are there hip bones poking out there? We can look in the hooks and the pins, tailhead area, how much fat or lack thereof. And really, when we're looking at these thinner animals, we're evaluating protein. How much muscling does she have? Does she have any extra fat in her brisket? Can you see her ribs? And these are all things that you kind of look at. When we look at this 5 cow, I mean, you can still see her transverse process right there, but you really can't see her ribs. You really can't see the top of her vertebrae. She's filled in nicely around the tailhead. You'd say that cow's in really good shape. This cow here is kind of on the obese side, or really on the obese side. You can see how much she's carrying in her brisket. You can see she's got these big old pones back here. She's carrying a lot of fat in her flank. You wouldn't even be able to probably feel her vertebrae if you touched her. So now the reason this is important, let's get this one. So the reason that we measure this is because really when we look at, we're evaluating protein and we're evaluating fat. So those are energy reserves, okay? Now in livestock production, rarely do we have a zero energy balance. So zero energy balance would be if you're not gaining weight, you're not losing weight. You're just steady state surviving. And rarely does that happen. We usually are milking and losing weight, or we're dried up and gaining weight, okay? So it's okay to be negative as long as we manage it properly. So I'm going to skip through a couple of these here. This is really what I wanted to show you on these last few slides. This is the relationship between body condition score, or we can say that body condition score, we are estimating her nutritional status. So these cows are not being fed very good. These cows are being fed good. Remember, our postpartum interval is the time from the time she calves until she cycles again. So at condition score 3, it takes her almost 90 days before she starts cycling again. If you remember, we'd had to have her bred by day 82 to maintain a yearly calving interval. So in these thin cows, this one's condition score 4 is day 70. We have very little chance, if any, to maintain that yearly calving interval. So we want to shoot for this condition score 5 or 6. They're cycling by day 60. If we're cycling on day 0 of the breeding season, and it's just for easy math, 20 days, we can go 0, 20, 40 days, we get 3 chances at it. So we got 3 chances to get her bred within that and maintain a yearly calving interval. Now, the obvious question, if you look at this table, is why wouldn't we want to push them to a condition score 7? She's cycling in 30 days. So I don't have the data with this, but conception rate actually dramatically goes down when we start getting obese. So these 5s and 6s breed really well. These 7s cycle like crazy. Even 8s cycle really good. They're standing in the heat. You think you're going to knock it out of the park. They don't conceive very well. So our conception rates go way down. I can't tell you mechanistically why that happens, but it holds time and time again. So maybe I'll just do a couple more slides here. This chart here, this is from old data. We actually put this together when I was at Purdue, and to me, it's a pretty cool chart, and I'll explain why. So if you think about, we just kind of went through body condition scores, right? We want them to be a condition score 5 so that they cycle really well. Well, from the time she calves until you breed, she's milking hard. It is really difficult to put weight on a cow. And if you can, it's probably not economical. So this is showing you how much weight you need. So let's say a good management practice would be to go in and evaluate our cows when we wean calves. We can look at them and say, okay, these cows are in really good shape. Let's just maintain them over the course of winter. Or we can say these cows are really thin. We need to bump them up. So in a cow that is in perfect condition, ideal condition at weaning, we want her to be that at calving, because from the time she calves till we breed, it's really hard to put weight on, okay? And that's going to be the next table. But so we want her to be in that condition score 5 by the time she calves. So in that scenario, if we were to run her across the scale, she's still going to gain 100 pounds without gaining any fat because of calf body weight, fluids and that sort of stuff. But that's not free energy. It's coming from somewhere. So she still has to actually gain that weight. So that's about just a little bit less than a pound a day that she needs to gain from the time you wean them until you calve them. So look at these other ones. If we are at a condition score weaning and need to be a condition score 5 at calving, and we've got 260 days or 150 days, I mean, we're pushing 2 pounds a day over the course of winter time. Now, she doesn't have any lactation demands, but her requirements go up and up as she's further along in pregnancy gets. And then you think about this cold weather and that wind blowing out there, requirements go dramatically up. So it's really difficult to put 2 pounds of gain on a cow over the wintertime if it's kind of a tough winter. So keeping records, managing them, really important. So look at this slide here. This is the exact same setup, but this time it's at calving, right? So if she's a 5 at calving, at 5 at breeding, we don't need to gain any weight. But let's say she's a 4 at calving, and we want to get her to a 5 by breeding. That's 80 pounds of weight, 60 days, so we got to gain over a pound. We could probably do that even in lactation, but you get down here and you're trying to put on 2, 3, 4 pounds a day. I don't know if it's possible. I've never tried, but it's certainly not economical if you could pour that much feed into it. So really important to monitor condition score. Has a dramatic effect on reproduction and your ability to get a cow bred. This is going to be the number one factor in your AI success rate of your AI in cows is what condition are they in. It's going to determine whether you get good success or not. Just to show you the change in requirements that happens between mid-gestation and early lactation. So average size cow, we get about a 25% increase from mid-gestation to lactation. We get a 80% increase from mid-gestation to early lactation, okay? So during pregnancy, they increase 25%, but from, middle of winter until she is in early lactation, we're gonna have an 80% increase in her energy requirements. So that's dramatic. So we need to make sure we're feeding it. Protein requirements. So think back to the last slide. She's already got an 80% increase in energy requirements. Now, if we're actually trying to gain weight, makes it even that much more difficult. It's the exact same story on crude protein requirements. 25% increase from mid to late gestation. 95% increase in our crude protein requirements to early lactation. So keeping up on our requirements, again, is going to help us maintain condition score, which is going to lead to whether we are successful in our reproduction or not. So I have some more stuff, but I think we'll stop there, and I'll save that for the next time we do this. Any questions? Any questions over any of that we've gone over?
I don't see any in the chat room either, Scott, so it looks like you're good.
Okay. Well, thanks. Hopefully I didn't go too fast. You can always email me if you have questions. My email is scottlake@uwyo.edu. It's SCOTLAKE, only one T in the email. So I'll get with you, Jonathan, and figure out how and when you want this test. So
Absolutely. Thank you, Dr. Lake, for joining us this evening, and everybody else that's on the call. The quiz will get posted probably by Monday, even into Tuesday. So don't look for it before then, but I'll get with Dr. Lake and we'll try and get it done by then. Does that work for you, Scott?
Yep. So yeah.
I'll get with you. Don't worry.
I just want to get with you on specifics, how many questions, that sort of stuff. So
Sounds good. Thanks,
All right.
everybody.
Thanks, guys.